Observer. A quiet shift has begun above you, subtle enough to escape most eyes, yet precise enough to guide you here. You didn't arrive by accident. Something in the deep sky has opened and you've stepped into the moment it revealed itself. What if an object we've never seen before appeared between fragility and Earth, not drifting but holding position as if waiting? What are the odds that a second tailless body would mirror the same impossible behaviour closer to the sun, yet refusing to shine the way physics says it must? Now let the noise fall away. Picture only a faint shape resting in the dark, a question suspended in motion. Stay with me. Let's drift a little deeper. Tonight the universe whispers again. Something faint moved across a telescope screen, a smudge almost too small to matter, yet enough to pull an old astronomer out of routine and into awe. For decades he had compared sky frames night after night, searching for changes subtle enough to hide from most eyes. Stars kept their places, asteroids drifted, predictably comets behaved like comets. But on that October night, the quiet was broken by a streak that did not belong. He leaned closer. Its motion was too steep, its vector too sharp, as if it had entered the solar system without the courtesy of slowing down. Discoveries of new objects are common hundreds each year, but this one held an unfamiliar stillness, a different signature in its path. And when he cross-checked its position, a chill moved through the room. The object sat directly in the line between Earth and 3i Atlas, the other anomaly that had already unsettled every model. Silence is the universe thinking, and that silence deepened. To understand why this mattered, we return to Gennady Borisov, whose name is carved quietly into astronomical history. In 2019, he discovered 2II Borisov, the second confirmed interstellar visitor, the first we could study for months. Before that, only Oumuamua had passed through too swift for prolonged study. Borisov became a symbol of improbable insight, a man who found things the universe seemed unwilling to reveal. And now 6 years later, he found another object that shouldn't exist. Within 48 hours, observatories across 5 continents confirmed the detection. The new visitor received its temporary designation C2025 V1 Borisov, a clean procedural name for something that was anything but procedural. Yet the true discomfort wasn't the name, it was the coincidence. Out of 20,000 skywatchers, why the same man twice? Statistically, the odds fell into the realm of impossibility, like lightning choosing the same square of Earth again. Some called it cosmic serendipity. Others wondered if serendipity was just a word for patterns we don't yet understand. But a designation is only the beginning of the story. Classifying an object as a comet carries assumptions: ice dust, volatile material, a coma that grows as sunlight warms its surface, and eventually a tail, the unmistakable plume that comets cannot hide. Yet this new object showed only a faint coma and nothing more. Listener, the absence of a tail where one should exist is not a small thing. It is a fracture in the foundation of cometary physics. Astronomers worldwide logged 147 observations. 145 agreed on the same conclusion: no tail. 2 amateur reports suggested something faint, but professional instruments contradicted them. Hubble saw nothing. The Very Large Telescope saw nothing. Planetary defense arrays saw nothing. Darkness where brightness should have bloomed. The sun's radiation at 0.7 AU should have carved a tail millions of miles long like it did with NEOWISE in 2020. Instead, the object drifted without shedding anything visible, as if absorbing the heat rather than reacting to it. This raised a quiet but heavy question. What kind of material could behave this way? The brightness implied an object nearly a kilometre across mountain-sized, yet mountains don't grow comae. If the coma existed, volatiles were escaping. But if volatiles were escaping, a tail should form, unless the outflow was perfectly symmetrical, cancelling its own shape. Possible, yes, but cosmic odds rarely favour perfection. So the mystery persisted, growing heavier with each night of stillness. The strangeness echoed the behaviour of 3i Atlas no tail. Persistent brightness, defiance of every rule. 1 anomaly demands study, 2 demand explanation. Patterns traveller are the universe's quiet way of drawing our attention, and here a pattern was forming a geometry in both behaviour and position. Borisov's object and 3 Atlas seemed connected not by origin alone, but by timing. Both were moving toward a November alignment, a nearly perfect straight line between Earth C2025 V1 and Thracius Atlas. The angular deviation less than 2 degrees, a cosmic bullseye. In astronomy, randomness rarely paints with such precision. Some wondered if this was coincidence. Others whispered that coincidence is often the mask of deeper order. Meanwhile, the Sun continued its restless work. As 3I Atlas slipped behind it in October, the object endured a violent gauntlet. 17 coronal mass ejections hurled plasma and magnetic wrath through its path, each one capable of stripping miles of material from any normal comet. And yet when it emerged weeks later, it remained intact, bright, silent, untailed. The Sun, that ancient sculptor of comets, had left no mark. Scientists reached for explanations rooted in what they knew: albedo shifts, refractory materials, exotic carbon shells, but none reconciled all observations. A reflective surface cannot maintain brightness without shedding. Diamond-like carbon can resist heat but cannot produce a coma. A volatile interior can vent but cannot avoid forming a tail. The paradox remained: something was coming off the object, yet nothing visible trailed behind it. Spectroscopic attempts offered even murkier answers. Instead of clear fingerprints, water cyanide hydroxyl. The readings were blurred, inconsistent. Dust contamination was possible but insufficient to explain the full absence of expected molecular lines. Whatever was venting from the object did not resemble any known cometary signature. Silence can be data too. When orbital analysts calculated the Tisserand parameter for C2025 V1, they found a familiar number, 2.3, interstellar territory, and 3 Atlas held 2.1. Two strangers from outside the solar system, both rejecting comet behavior, both drifting into alignment. Somewhere beyond our reach, something ancient still moves. Some astronomers posed the quiet possibility that these objects shared a source. Not fragments, but companions. Not debris, but deliberate travelers from a distant region of the galaxy. Others avoided the thought entirely, not out of disbelief, but out of caution. A hypothesis can echo loudly even when spoken softly. Yet as I sit with these observations, these fragmentary truths, the night feels less threatening than contemplative. The universe has always been patient, revealing itself in pieces small enough not to overwhelm us. And in these anomalies I sense not danger, but invitation. A gentle urging to widen the frame of what we consider possible. It's all right to not understand. For in the quiet between what we know and what we fear, wonder often slips through. And tonight, as the cosmos rearranges its pieces, one faint smudge of light reminds us that mystery is not a threat but a bridge. One we may cross slowly, breath by breath, as the stars continue their endless conversation above us. The pattern emerging between these two objects lingered like a soft echo in the back of every observatory on Earth. Scientists are trained to resist premature connections, yet the symmetry was difficult to ignore. Two bodies from interstellar space, both shedding something without forming a tail, both maintaining brightness against prediction, both drifting into alignment as though following steps in a celestial choreography older than our physics. Sometimes the universe arranges its pieces so quietly that only patience can reveal its intention. As astronomers traced the motion of C2025 V1, they expected differences to emerge, something to break the pattern before it solidified. But each new measurement seemed to deepen the mystery. Its coma remained faint but persistent, its silhouette unchanged, its behavior calm in a region where comets rarely remain calm for long. Heat should have sculpted it. Radiation should have carved it. Yet the object glided steadily as if insulated by something unseen. Silence is the universe thinking, and this silence was meticulous. In their frustration, some teams turned back to 3I Atlas, hoping that by understanding one they could understand the other, but 3I Atlas had already defied their expectations during its solar passage. While enveloped in storms of plasma and magnetism, it refused to fragment or dim. Typical comets leave trails of their suffering scars of lost material, but this object emerged unchanged, almost serene. That serenity unsettled people in ways they could not quite articulate. Objects in space are not supposed to endure the sun's violence without consequence. The comparison stretched into deeper scientific territory: composition, reflectivity, thermal resistance. Materials such as carbon shells, metallic cores, refractory compounds, even theoretical substances were put on the table. Each theory solved one part of the puzzle but broke another. If the shell was too strong, there should be no coma. If the interior was volatile, a tail should manifest. If both existed simultaneously, the combination defied known formation processes. These contradictions settled into a heavy stillness like the pause before a revelation. Attempts to analyse the spectral signatures added yet another layer of strangeness. Normal comets sing in the wavelengths they emit water vapour-lined sodium flares carbon compounds, but these objects whispered in tones that did not match any familiar patterns. Dust may have obscured the truth, yet even dust has its own spectral rhythm. What appeared instead was ambiguous, irregular, and incomplete, as if the object were revealing only fragments of its nature, never the whole. Mathematically, the interstellar origin was the most difficult point to dismiss. The Tisserand parameters for both bodies fell neatly below the boundary reserved for visitors from beyond. Their motions did not curve through the solar system like returning residents, but swept through it like travellers passing by a fire for warmth before continuing their journey. Yet their paths, independent as they appeared, carried a strange coherence, as though guided by something more deliberate than gravitational chance. Meanwhile, as the days shortened toward November, astronomers found themselves catching their breath whenever the alignment was mentioned. A straight line may seem ordinary on Earth, but in the geometry of planets, an interstellar debris precision rarely arises unprompted. To see Earth, a newly arrived interstellar object, and a long-studied anomaly fall into a neat configuration felt less like randomness, and more like an unfolding page of a story no one knew they were reading. Some quietly calculated the odds not to prove anything, but to soothe themselves with numbers. Yet the numbers offered little comfort. When probability collapses into near impossibility, uncertainty grows. People begin to feel the weight of meaning where none may exist or where too much exists. Tonight, somewhere beyond our reach, something ancient still moves, and even the most grounded scientists felt its presence whispering through the data like wind through distant grass. The conversation that followed was not loud. Science rarely shouts. Instead, a calm tension stretched across universities and research centres, an unspoken agreement that the anomalies were no longer isolated curiosities. This was a pattern, and patterns require explanation. But explanations require time, and time felt thinner with each approaching night. The alignment was no longer a date on a calendar, it had become a horizon, a line in the dark toward which all thoughts seemed to drift. Humanity has always struggled with the unknown. In ancient times, the sky was a map of stories meant to soothe fears. Now, with instruments capable of piercing the depths of space, the fears have grown more precise. We know how comets behave, how radiation shapes matter, how trajectories bend under gravity's quiet hand. When those rules break even gently, something in us stirs, curiosity for some, unease for others. And yet beneath both a shared humility surfaces, we do not know everything. Some astronomers found comfort in recalling that the universe has always challenged its own rules. Quasars, pulsars, dark matter all arrived as confounding whispers before becoming accepted truths. Perhaps these objects too belonged in that lineage, waiting patiently for us to catch up. Others sensed something more elusive, something that brushed the edge of intuition rather than analysis. Patterns are ancient teachers, and this pattern did not feel accidental. Yet amid all speculation, the sky remained calm. No sudden flare, no unexpected shift. Just two faint objects drifting in quiet arcs, carrying questions instead of answers. It is all right to not understand. The cosmos rarely grants clarity before its time. Instead, it teaches us to sit with uncertainty, to breathe into the spaces where knowledge has not yet taken root. As telescopes continued their watch, a hush settled over the scientific world, a collective recognition that something was unfolding too slowly to grasp, yet too symmetrically to ignore. We often believe we guide our discoveries, but sometimes discoveries guide us, leading us gently toward new frames of understanding. These objects, silent and unmoving in their defiance, seem to offer such guidance. Between what we know and what we hope to know, between the familiar rhythm of cometary science and the quiet dissonance of two interstellar visitors that refuse to behave. The night holds its breath, and so do we, listening for whatever truth might rise from the dark. As the nights deepened, researchers turned their attention to a question that had lingered beneath every conversation. If these objects were shedding material without forming tails, where was the missing momentum? Comets are not gentle. They create pressure, asymmetry, turbulence. Yet these two visitors travelled as though wrapped in equilibrium, their motions smooth, unperturbed by the small forces that normally carve deviations into a comet's path. It was as if something within them held their balance steady, a stillness carved into motion itself. Teams across the world attempted simulations. They adjusted compositions, densities, heating rates, rotational patterns. Nothing matched reality. A perfectly uniform outgassing model reproduced the tailless behaviour in theory, but only briefly. Over weeks, slight irregularities would accumulate, breaking the symmetry. These objects, however, had maintained that symmetry for months. A model that required perfection clashed with nature's inherent chaos. The cosmos tends toward entropy, not precision. This led some to revisit the internal structure hypothesis. Perhaps the comets were not escaping from scattered points, but from specific vents aligned with the rotational axis. If both objects spun in a way that hid their emissions, the lack of a visible tail might be explainable. But when astronomers measured rotational light curves, they found no rhythm. No periodic dimming, no clear indication of spin. The objects behaved like bodies without rotation, an impossibility for anything drifting freely through space. In the quiet between observations, the paradox grew darker. Smaller observatories began reporting subtle fluctuations in brightness, though none were consistent. Some teams dismissed them as noise, but others felt they hinted at something more complex, like a pulse too slow to recognize in real time. The universe sometimes expresses itself in long breaths, changes unfolding across spans beyond human intuition. If these objects carried such rhythms, our instruments might only be catching fragments. Somewhere beyond our reach, something ancient still moves. Meanwhile, discussions around the November alignment evolved. What began as curiosity slowly took on the weight of inevitability. The date approached like an eclipse, predictable, unavoidable, steeped in quiet significance. Scientists spoke about it carefully, not wanting to imprint fear on a public already restless with speculation. But within closed rooms, the unease was genuine. Alignments are not inherently meaningful, yet some geometries carry a sense of intention even when one tries to resist that thought. A few researchers wondered whether gravitational interactions could explain the precision. Perhaps the two objects were influencing each other, subtly adjusting their trajectories through faint exchanges of mass or dust. But their distances were too great for such delicate coupling. To shape each other's paths across millions of miles would require forces neither possessed. Gravity is a patient sculptor, not a painter of exact lines. At the same time, humanity's instruments continued their steady watch. Arrays measured radio noise, spectrographs tracked spectral signatures, deep space detectors listened for faint particles. Most found nothing new, but the absence itself began to feel like information. In science, silence can be a data point. When the universe withholds fluctuations, it may be telling us where to look or where not to. Late one evening, a small team analysing archival data noticed something subtle. Both objects showed slightly elevated thermal signatures compared to standard comet models. Not warm by human standards, but warmer than expected for bodies without active tails. The difference was small, almost ignorable. Yet the more they checked, the more consistent the anomaly became. Heat without sublimation, activity without turbulence. It echoed like a soft hum beneath the surface. What mechanism could generate warmth while preserving outward stillness? Decay of radioactive isotopes was one option, but the levels needed would be extreme and inconsistent with interstellar origins. Chemical reactions seemed unlikely in a vacuum. Mechanical processes, internal friction flexing, felt even more distant from nature's tendencies. The researchers hesitated to publish their findings, aware that speculation could spiral beyond control. Still, the pattern was there, objects warm enough to bother the models, yet calm enough to defy them. When shared quietly across networks of astronomers, the data sparked contemplation rather than conclusions. In the cosmic scale of mysteries, this was a soft one, a subtle nudge of curiosity rather than alarm. It's all right to say it. To not understand. Some physicists propose that both bodies might harbour cavities filled with warmer gases, gradually seeping through small apertures. This could produce faint comae without directional tails, but such formations would require coincidental similarity between two unrelated interstellar wanderers. Coincidence is possible. Repetition is something else. Patterns as always implied deeper order. Others turned their attention to the object's positions relative to the solar wind. The wind can shape delicate dust structures, sometimes suppressing tails under specific magnetic conditions, but these conditions change constantly, yet the objects did not. They remained steady across shifting solar environments as if indifferent to the wind's touch. Even seasoned experts found themselves lingering on that thought longer than they intended. As November drew nearer, the mood in observatories shifted from analysis to reflection. People stayed later than usual, not out of duty, but out of quiet fascination. There is something profoundly human about watching the unknown approach, knowing it is indifferent, knowing it carries neither promise nor threat, only presence. These objects, silent and deliberate in their behaviour, invited that kind of contemplation. In moments between calculations, some astronomers admitted privately that the mystery had become personal, not because they feared it, but because it reminded them why they had devoted their lives to the sky. The universe is vast enough to humble any certainty. These anomalies, drifting through the dark with impossible grace, restored a sense of wonder many had forgotten amid deadlines and data sets. The cosmos, in its own patient way, had given them a reason to listen again. The closer the alignment approached, the more researchers found themselves returning to one detail that seemed too subtle to carry weight, yet too persistent to ignore. Both objects held their brightness with an unusual steadiness. Most comets brighten and dim in pulses as sunlight strikes rotating surfaces. These two, however, shimmered with quiet consistency, as though illuminated from within by something slower, deeper and less chaotic than reflection alone. Light curves normally betray imperfections. Here the curves felt almost meditative. Intrigued by the stability, teams revisited their brightness models. At first they suspected measurement bias, instrument, calibration, atmospheric interference sampling gaps. But cross-referencing data from dozens of observatories revealed the same calm behaviour. Even under strong solar radiation, neither object flickered in the ways comets typically do. Their luminosity felt anchored as though governed by an internal rhythm rather than the sun's shifting angles. Silence is the universe thinking, and this glow seemed part of that thought. As more data arrived, a quiet debate took shape around the question of inertia. Heat radiation, particle bombardment. These forces should have altered the surfaces, yet the objects remained unmoved in both appearance and pattern. This wasn't resistance in the dramatic sense, but a kind of patient endurance. If the cosmos were turning a page, these two bodies appeared printed in ink that did not smear. Researchers found themselves pausing over the numbers, sensing something steady beneath the calculations. Some wondered whether these objects had undergone transformations before entering the inner solar system. Perhaps they had already shed their volatile layers far from the sun, leaving hardened remnants behind. But this did not explain the faint comae, nor the apparent warmth, nor the persistent glow. Others speculated about ancient interstellar erosion processes, slower than geology and older than human memory. In the quiet hours of analysis, these thoughts drifted like dust through a beam of light, soft, unprovable, and strangely comforting. Meanwhile, discussions turned toward motion once again. Though subtle, each object's path remained astonishingly clean-free from the minor deviations that typically arise from jets of gas or rotational asymmetry. Even spacecraft, with their engineered stability, experience micro-forces that must be corrected. Yet these objects glided through the solar system, with the ease of stones carried by a gentle current. The solar wind pressed them, but nothing in their movement betrayed struggle or imbalance. A small group of orbital dynamicists toyed with the idea of natural damping and an internal configuration that absorbs minute shifts. Their simulations suggested that hollow structures or layered shells could potentially dampen rotational variations. It was a bold hypothesis bordering on speculative but not impossible. Nature can be unexpectedly intricate. Even simple bodies like asteroids sometimes reveal complex rubble pile interiors. Still, the symmetry needed for such damping in two unrelated interstellar travellers seemed improbable. Thermodynamic models deepened the intrigue. As both objects neared regions of higher solar flux, temperature readings rose but not abruptly. The heating curve was graceful, matching neither purely rocky nor icy compositions. Something moderated the absorption, producing a thermal signature more even than expected. If the surfaces were dark, they should have heated sharply. If reflective, they should have remained cooler. Instead, the temperatures followed a middle path, as though moderated by a balanced mixture of materials or an unusual structural geometry. In the quiet corners of research forums, scientists shared contemplations rather than conclusions. Some compared the behaviour to meteorites coated in fusion crust's thin, dark layers, formed during violent atmospheric entry. But these objects had not passed through atmospheres. Others likened them to the carbonaceous asteroid that remained surprisingly intact under heat. Yet again, the presence of Comier contradicted the comparison. Each analogy solved one riddle only to revive another. The closer the date drew, the more the focus shifted from composition to context. What mattered was not merely what these objects were, but what they were doing here now together. Their alignment with Earth and each other carried the sensation of synchronized timing, neither rushed nor delayed, simply precise in a way that nature seldom insists upon. In astronomy, timing is often noise. Here it felt like intention, though no one dared use that word officially. As telescopes continued tracking the objects, small fluctuations began appearing in the surrounding dust fields. They were faint, almost unnoticeable, tiny ripples in the density of reflected particles around each body. Some dismissed them as solar wind artifacts. Others saw patterns that looked too organized to ignore. If the dust clouds were interacting with the solar wind in unusual ways, perhaps the surfaces were textured or porous in ways not yet considered. Further analysis suggested that the particles surrounding the objects were unusually uniform in size, unlike typical comet dust, which ranges wildly from fine grains to large fragments. This uniformity puzzled researchers. Natural processes rarely create such regularity, but the data held. The dust behaved more like a thin mist than a debris field, drifting in harmony with the objects, rather than dispersing erratically. The thought lingered. Quietly, harmony is not a property comets often possess. Through all of this, the alignment loomed with gentle inevitability. It was not an event in the theatrical sense, no flare or burst expected, but a moment of geometry, a soft convergence of paths. Scientists prepared instruments, calibrated detectors, and rehearsed observation protocols. Yet beneath the precision lay something more human, a shared awareness that they were witnessing a curiosity without precedent. The universe had arranged a meeting, and humanity was quietly taking its seat. As midnight approached in observatories around the world, researchers found themselves slowing their movements without realizing it, speaking in softer tones, touching their keyboards with more care. The approach of a mystery changes the atmosphere in ways that cannot be measured. Somewhere a spectrograph hummed gently. Somewhere else a radio dish whispered to the sky, waiting for nothing in particular and everything at once. In moments like these, the boundary between science and wonder becomes thin. Equations rest beside questions with no answers. Data sits beside intuition. And the cosmos, vast and unhurried, continues its quiet unfolding. The objects drifted on, steady in their silence, carrying with them the possibility of understanding just beyond reach. The night deepened, and so did humanity's listening. The days leading up to the alignment brought a gentle pressure into every observatory hall, not of fear, but of anticipation shaped by careful thought. People spoke less, listened more, and found themselves gazing at the updated trajectories with a kind of reverence. Each revised plot carried the same message: the three bodies, Earth C 2025, V1 and Thruwam Atlas, continued their quiet convergence with unwavering precision. The lines felt almost deliberate, as though the cosmos were drawing something in the dark, Teams began comparing the two objects in deeper detail, studying their shared resistance to classical explanations. Both maintained consistent brightness. Both showed comae without tails. Both displayed thermal behaviour that settled into the same quiet middle ground. Nothing about these parallels felt accidental, though no one could yet speak the language of their meaning. Silence became a common companion in the labs, the kind that invites contemplation rather than discomfort. As researchers reviewed historical records of other interstellar visitors, they found no useful precedents. Oumuamua had been too swift to observe long enough. 2I Borisov had behaved like a conventional comet shedding material in bright arcs. But these two new bodies defied both categories. They were neither fast nor chaotic. Their motions felt unhurried, their signatures steady as if they were conserving something more important than velocity or heat. This steadiness became a point of fascination. In nature, even resilience displays irregularities, fractures, bursts, peaks of activity. Yet nothing in the data hinted at internal turbulence. No sudden jets, no rotational stutter, nothing that betrayed stress. It reminded some researchers of deep sea creatures whose bodies move with slow grace in environments too harsh for noise. The thought lingered. Perhaps these objects travelled through the galaxy the way those creatures drift through darkness. Patient, durable, unconcerned with observers. Attention shifted again to the surrounding dust. Though faint, the haze around each object behaved differently from typical comet dust. Rather than dispersing outward, it remained in a thin envelope that shifted gently but maintained cohesion. Models suggested electrostatic interaction, but the stability exceeded what such forces could typically maintain over time. This dust drifted as though bound by a subtle order. Somewhere beyond our reach, something ancient still moves. Astronomers began asking a new question, not what these bodies were made of, but what preserved their shape and behaviour across such vast distances. The galaxy is not gentle. Interstellar space is full of radiation collisions, dust, and gravitational encounters. Yet these objects seem to carry no scars. Their surfaces did not show dramatic variation in brightness. Their comae did not fluctuate wildly. They drifted like travellers who had weathered storms so often that storms no longer left marks. Meanwhile, public awareness rose. People around the world followed updates quietly the way one watches a distant lighthouse during a long night. Many felt the significance even if they could not articulate it. The alignment was not framed as a threat, but as a moment of convergence, 3 points in space, falling into a line no one had expected. In a world accustomed to noise, this calm event felt almost sacred. In scientific circles, conversations grew more philosophical. Some wondered whether the alignment held meaning beyond geometry. Others insisted that nature sometimes produces patterns that look intentional but are not. Yet beneath the rational explanations lay a deeper feeling, an almost spiritual recognition that the universe occasionally pauses its chaos to show us something rare, and rare things deserve attention. In the days before the event, radio telescopes increased their monitoring frequencies. Optical arrays adjusted their exposure plans. Space agencies coordinated observation windows with unusual cooperation. There was no directive, only a shared sense that this moment should not pass undocumented. Data mattered, yes, but so did witnessing. Humanity listens differently when the universe grows quiet. During long nights of preparation, some astronomers began writing reflections in their logs. Small notes not for publication but for memory. These entries spoke of humility, of the comfort found in not knowing of the strange peace carried by distant mysteries. To them, these objects were reminders that science is not only analysis but communion with the unknown. To watch something inexplicable is to stand at the shoreline of deeper truth. The objects continued their slow drift inward. At times, their comae shimmered faintly, responding to sunlight with gentle defiance. At other times, they seemed nearly inert, as though conserving energy for reasons beyond our understanding. Their silence never felt empty. It felt intentional in a way that eclipsed language. It's all right to not understand. And as the final days approached, the sense of collective pause deepened. Observatories dimmed their interior lights. Servers hummed with quiet purpose. Researchers sat before their screens as if waiting for a guest they did not know how to greet. No one expected spectacle. No one expected revelation. They simply expected presence, a moment where the sky for a heartbeat aligned its pieces in a way that touched something ancient within us. The night before, the alignment clouds drifted over some telescopes and spared others. But even those obstructed found comfort in knowing that countless lenses, dishes and instruments around the planet held their watch. The universe does not require every eye, only a few steady ones willing to listen. And humanity, with all its imperfections, had managed to provide them. As the morning of the alignment approached, the world's instruments were already awake. Antennas rotated gently toward the sky, optical lenses cooled to their observing temperatures, and arrays waited in a stillness that felt almost ceremonial. It wasn't urgency that filled the air, but a soft readiness and understanding that whatever happened, or did not happen, the universe would speak in its own language. And humanity for once was quiet enough to hear. In research centres, people refreshed trajectory plots not out of doubt but out of ritual. The paths remained unchanged, the alignment held steady, and nothing in the numbers wavered. The calmness of the data became its own message. When nature intends chaos, it leaves clues, jitter, drift, fluctuation. Here the curves flowed smoothly without tremor. Silence is the universe thinking, and this stillness felt contemplative. Across time, Zone scientists compared notes, each finding reassurance in the symmetry of their observations. There was something strangely grounding about knowing that every telescope from backyard setups to billion-dollar observatories was tracing the same gentle arcs across the firmament. The unity of purpose created a quiet bond between those watching the sky. Even disagreements softened into thoughtful murmurs as though the alignment had tamed the very tone of discussion. The objects themselves continued their steady glide. C2025 V1 remained faint but distinct, its coma shimmering like a held breath. Through Atlas drifted farther, its brightness persistent in a way that defied simple photometry. Both bodies felt less like visitors and more like distant thoughts carried through space. Intentional or not, they held presence. Their silence felt lived in, like something that had travelled a very long time without needing to announce itself. In the hours before the alignment, a few observatories detected faint fluctuations in the solar wind. Nothing dramatic, just small ripples that brushed past the instruments like soft gusts of unseen weather. These changes were not attributed to the objects. The sun has moods of its own. Yet the timing added another subtle layer to an already contemplative moment. The universe rarely gives only one variable to consider. Researchers tracking background radiation noted slight shifts as well, though still within expected limits. The cosmos is a sea of low murmurs, and sometimes those murmurs swell. But even these fluctuations felt gentle, as though the sky itself were taking a slower breath. Somewhere beyond our reach, something ancient still moves. Throughout the scientific community, people found themselves reflecting more than analysing. The mystery had stretched long enough that the desire for resolution softened into acceptance. Many realised they no longer craved answers. What they wanted was understanding, or at least the comfort of being present for whatever might unfold. It became a shared meditation, a planetary pause. Somewhere in Chile, an astronomer stepped outside her observatory dome and looked up without equipment. She admitted later that she wanted to see the sky with her own eyes, to feel the moment without the filter of technology. Others around the world did the same. The sky looked no different than any other night yet. Something in it felt attentive, as if the cosmos were aware of being watched. Inside control rooms, monitors displayed synchronized countdowns to the alignment. There were no alarms, no flashing indicators, only simple markers of time sliding gently toward the predicted moment. People sat quietly, some with hands folded, others leaning back in their chairs or waiting for a change none could define. Even those who believed nothing unusual would happen felt the significance of reaching the threshold. When the moment arrived, it did so without ceremony. No spike in radiation, no sudden brightening, no deviations in trajectory. The objects simply occupied their positions in the vast geometry of space Earth, C2025 V1 and 3 Atlas, resting in a line that stretched from our world into the deep, dark beyond. A perfect alignment drawn in silence, Observatories captured spectra radio traces thermal signatures and particle interactions. Data streamed into servers across the planet, collecting layer upon layer of cosmic whisper. Some teams held their breath, waiting for a signal. Others listened for any disturbance, any anomaly that might bloom into meaning. Yet the sky remained calm. But calm does not mean empty. Within the seemingly ordinary numbers, certain patterns hinted at subtlety, a faint coherence in background noise, a delicate shift in phase, angles, a softness in thermal response. None were enough to declare discovery. All were enough to inspire contemplation. The universe rarely speaks in shouts. After the alignment passed, the sky looked unchanged, yet the observers felt altered. They had witnessed a moment written not in spectacle, but in precision, a geometry that asked nothing, explained nothing, and offered only presence. It's all right to not understand. Sometimes the significance of a moment is not in what happens, but in how deeply we listen. Researchers returned to their screens with a gentle realism. They knew the days ahead would be filled with analysis, debates, and interpretations. Yet beneath that, an awareness had settled in a recognition that wonder itself is a kind of data, one that reveals more about us than about the cosmos. And perhaps that is what the alignment truly measured: our capacity to hold mystery without closing our minds around it. The objects drifted onward unchanged, and humanity, having paused to meet them in silence, returned to its instruments with renewed humility. In the hours after the alignment, scientists found themselves moving more slowly, as though their bodies still echoed the calm geometry they had just witnessed. The data streams continued flowing, but urgency no longer accompanied them. Instead, there was a quiet devotion in the way researchers examined each line of information. What mattered now was not confirmation of expectation, but the gentle act of noticing what the universe had chosen to reveal and what it still chose to withhold. Teams began comparing results from radio telescopes across continents. Most recordings showed nothing unexpected, only the familiar hum of cosmic background. Yet scattered within the noise, certain patterns appeared slightly more structured than usual, like faint ripples on a still pond disturbed by something distant. They were not strong enough to claim as signals, nor random enough to dismiss. They lived in a liminal space, half data, half whisper. Silence is the universe thinking, and this silence carried texture. Optical observatories reported similarly subtle outcomes. No sudden brightening, no fluctuations that hinted at internal change. The objects seemed content to remain themselves, drifting forward, as if nothing remarkable had occurred. But to the people observing them, their constancy felt profound. There was something deeply grounding in seeing the cosmos continue its quiet work unchanged by human anticipation. It reminded many that the universe moves in scales of time far larger than our expectations. In some labs, discussion shifted to the philosophical implications of the non-event. If the alignment produced no visible transformation, what then was its purpose, if purpose existed at all? Some argued that geometry alone holds meaning, that alignment is itself a message in the language of motion. Others suggested that humans project intention onto patterns, because patterns soothe uncertainty. But even in disagreement, the tone remained soft. The sky had modelled stillness and people mirrored it. Many returned to studying the unusual coma that first sparked curiosity months earlier. Now, with new measurements collected during the alignment, researchers hoped for subtle insights. The dust envelopes remained as faint and orderly as before. Their symmetry persisted in ways that natural processes rarely maintain for extended periods. Even the density gradients aligned smoothly with predicted curves, yet the curves themselves remained unexplained. To conform to an unknown rule is still a mystery. One team noticed something intriguing in thermal readings. During the alignment, the surfaces of both objects cooled slightly more slowly than expected. The change was minimal, just enough to rise above instrument error, but consistent across multiple observatories. In the vacuum of space, thermal behavior is often predictable. Here the retention of warmth felt deliberate, as if the objects absorbed heat differently than assumed. Theories arose cautiously, none fitting perfectly, but all adding nuance to the growing portrait. Elsewhere, analysts revisited orbital models. The alignment had provided fresh reference points, allowing trajectories to be recalculated with improved precision. The updated paths matched predictions almost perfectly, so perfectly in fact that the precision itself became a topic of fascination. Perturbations from solar wind, gravitational interactions and microdust collisions should have nudged the objects by at least minor margins. Yet those margins remained smaller than expected. Harmony once again revealed itself in motion. Amid all this, the human element continued to shine quietly. Students who had stayed awake through long nights found themselves speaking softly about how the experience had changed their sense of scale. Senior researchers wrote reflective notes about gratitude for the chance to witness something rare, something that stirred their curiosity without demanding resolution. In a world that often chases definitive answers, these objects had offered a lesson in patience. Somewhere in an observatory nestled in mountain air, a researcher gazed at the latest photometric readings and felt an unexpected calm. The numbers were ordinary, but their ordinariness held elegance. In unpredictability, humans often feel urgency. But in subtlety there is comfort. These objects did not intrude upon the solar system. They passed through it lightly, carrying their mysteries without imposing them. It's all right to not understand. Conversations soon turned to whether the alignment might hold value over longer timescales. If the objects continued their trajectories without change, would future alignments occur? The answer was no, at least not within human lifetimes. Their paths diverged, their speeds differed, and their distances from Earth would continue growing. This moment had been singular, only possible within a narrow window. Knowing this lent it even more quiet significance. Observatories prepared for the objects' gradual fading. As they moved farther from the sun, their brightness would diminish, and eventually only the most sensitive instruments would track them. This realization introduced a gentle sadness to the atmosphere. For months these objects had been companions to the scientific community, enigmatic, steady present. To watch them recede felt like watching a ship drift over the horizon, shrinking but never truly leaving the mind. Yet even with that melancholy, there was a sense of closure forming, not because the mystery had resolved, but because the experience had completed its arc. Sometimes understanding does not arrive through explanation, but through acceptance. What these objects were, how they formed, why they behaved so gently, those answers might never come. And still their presence had shifted something within every person who had followed their paths. As night fell, around the world once more laboratories dimmed their lights, and the sky resumed its ancient rhythm. The two objects drifted outward, their commi faint, their silence unchanged. The universe had not been loud today, nor had it been empty. It had simply offered a moment of alignment, a moment to listen more deeply, to breathe more slowly, to see more clearly the scale of the unknown that surrounds us. The data would continue to be studied, of course. Papers would be written, theories would rise and fall, but beneath all that, something quieter endured a soft recognition that mystery can be gentle, not overwhelming, and that even in the absence of revelation, the journey of attention holds meaning. The cosmos waits for no one, yet it allows us to follow when we choose to look up steady and open to whatever we find. In the days that followed, the world of astronomy settled into a quieter rhythm. The alignment had passed, the moment had come and gone without spectacle, yet its presence still lingered in every discussion. Researchers found themselves returning again and again to the streams of collected data, not out of pressure, but out of gentle curiosity. Something about the stillness of the event invited deeper reflection, as though the universe had whispered instead of spoken, leaving humans to decipher the tone rather than the words. Much of the early attention focused on the spectral measurements gathered during the alignment. When analysts compared the observations from multiple facilities, they noticed delicate variations that were nearly invisible on their own, but more pronounced when layered together. A faint shift in emission lines, a subtle cooling in the dust envelopes, tiny changes in reflectivity that did not indicate transformation, only slow breathing. These nuances felt like the quiet settling of dust in a sunbeam, ordinary yet strangely meaningful. Some teams proposed that the alignment offered a unique angle of illumination, allowing sunlight to interact with the comets in ways not seen before. This explanation was comforting, grounded in familiar physics. But even so, the elegance of the data seemed disproportionate to randomness. Natural processes often leave jagged signatures, sharp rises, sudden dips, abrupt irregularities. Here the curves followed gentle slopes like waves sliding across a calm shore. At radio observatories, analysts revisited the recordings of cosmic background noise that had briefly displayed structured ripples. After days of examination, most agreed the patterns were likely atmospheric artifacts or subtle solar influences. Yet a small group remained unconvinced, pointing to the coherence in the fluctuations. They resembled not signals, but harmonics resonances created by interactions between natural forces. Somewhere beyond our reach, something ancient still moves, and sometimes its motion creates patterns too soft to categorize. Meanwhile, the faint dust envelopes surrounding both objects remained a highlight of study. The uniformity of particle size puzzled experts. In comets, dust is sculpted by eruptions, collisions, and radiation pressure, producing wild diversity. But the dust around these bodies drifted with surprising consistency, forming a cloud more reminiscent of mist than debris. It was not dense enough to alter brightness significantly, yet structured enough to behave as a single entity. Researchers debated whether this cohesion was simply the natural result of similar formation histories, an echo of some distant region of interstellar space. Thermal models continued evolving. As the objects receded from the Sun, their cooling rates again diverged from prediction. Instead of rapid temperature loss consistent with low-density ice, both cooled slowly, maintaining warmth longer than expected. It wasn't startling, only curious. The universe rarely maintains perfect pace with theory, but the consistency across two independent bodies kept raising eyebrows. Equations bent slightly around the data like branches adjusting to the wind. Observatories also monitored the solar activity during and after the alignment, curious whether the objects responded to fluctuations in the heliospheric environment. The Sun had emitted mild bursts during the window, yet neither object showed a noticeable reaction. Their comae neither expanded nor contracted. Their brightness remained level. Their trajectories stayed smooth. They drifted through the changing conditions with quiet resilience, as if carrying an internal equilibrium that sheltered them from external influence. The scientific community, once animated by expectation, now embraced a more contemplative mood. The alignment had not revealed answers, but it had deepened appreciation. Mystery, when approached, slowly becomes a companion rather than a barrier. Conversations in labs softened into reflections on the nature of discovery, how sometimes the universe grants clarity and other times it offers only presence. Presence in its own way can be a form of knowledge. Some researchers speculated that the objects might now enter a long phase of gradual fading. As their distances increased, their comae would dwindle, their light would dim, and their signatures would eventually blend into the background of deep space. Instruments would continue tracking them, but the intimate closeness felt during the alignment would fade. This realization brought a sense of quiet melancholy, like watching the last glow of a distant lantern drift into the night. Yet even as the objects began to recede, their impact remained. For months they had drawn the global scientific community into a shared moment of curiosity. Observatories had collaborated across borders. Researchers had compared data more freely. Students had watched their mentors speak with wonder rather than certainty. In a subtle way, the anomalies had encouraged a kind of unity, a recognition that beneath our divisions humanity is bound by the same sky. A few theorists revisited older, broader questions: what do anomalies teach us about our assumptions? Often the most profound shifts in science arrive not through grand revelations, but through persistent, gentle contradictions, data that bends theory until theory must evolve. Perhaps these objects would someday catalyze such change, or perhaps their significance rested not in transformation, but in invitation, an urging to think more slowly, more widely, more humbly. As days passed, the public conversation softened too. The excitement around the alignment faded, replaced by a quieter appreciation for the event. Many had followed the journey with awe. Some expected spectacle, others feared it. But in the end, the universe had behaved like itself, calm, vast, indifferent, yet strangely comforting. It's all right to not understand. And in the scientific world, the work continued. Papers were drafted, data was refined models, updated, but beneath the technical details something subtler remained, a memory of a moment when humans paused together to listen, even without knowing what they hoped to hear. The alignment had offered no proclamation, no cosmic signature, only stillness. And sometimes stillness is the most mesmerizing part of the universe. The two objects continued their drift outward, carrying unanswered questions with them. Whether they were natural oddities, ancient wanderers, or something shaped by distant processes we have yet to fathom, they had already done something rare. They had reminded humanity that wonder is a scientific resource too, one that guides inquiry as surely as data. They would fade, yes, but their presence would not vanish. It would simply settle into the quiet places of thought, waiting to be revisited whenever we gaze at the sky, and remember the weeks when the cosmos felt a little closer, a little softer, and infinitely more mysterious. In the weeks after the alignment, the two objects continued their outward drift, and astronomers found themselves moving into a new phase of observation, one shaped not by anticipation, but by reflection. As the bright urgency of November faded, a quieter rhythm took hold. The datasets grew steadier, the questions gentler, and the tone across research centres softened into something akin to gratitude. The cosmos had not revealed a secret, but it had offered a moment of profound stillness. Scientists reviewing long-term photometric data noticed a faint trend emerging. Both objects dimmed slightly slower than models predicted. The change was modest, like the difference between a candle extinguishing at dusk instead of midnight, but persistent. Natural comets lose brightness quickly as their activity dwindles. These two faded as though conserving heat, releasing it with patience rather than haste. It wasn't a violation of physics, only a gentle bending of expectation. Some astronomers proposed that the objects might have unusually low emissivity surfaces that radiate heat less efficiently than typical cometary material. But this led to another puzzle. If their surfaces were so poor at radiating heat, why had they formed coma at all? Volatile material should have sublimated slowly, faintly, irregularly. Instead, the comae remained consistent in shape and density both before and after the alignment. Harmony again where chaos should rule. Meanwhile, spectroscopic teams revisited the chemical fingerprints gathered over several months. Though inconclusive, the recordings held subtle features that deepened the mystery, slight deviations in the expected absorption lines, hints of dust with unusual grain structures, faint emissions that did not correspond cleanly with known volatiles. These details suggested not alien composition, but unfamiliar histories, journeys through regions of interstellar space rarely sampled by anything we can detect. Somewhere beyond our reach, something ancient still moves, and these bodies may have carried traces of places we have never imagined. Orbital dynamicists noticed something else. The trajectories of both objects remained remarkably smooth, even as they receded from the inner solar system. Most bodies experience small perturbations, gravitational nudges from planets' gentle pressure from solar radiation. Yet the curves of these objects continued their slow arcs without visible wobble. This steadiness was not alarming, only elegant. Motion can be poetry when the cosmos allows it. Across the scientific world, conversations began shifting from the objects themselves to the experience of studying them. Researchers reflected on how these months had altered their sense of scale, reminding them that discovery is as much about perception as data. One astrophysicist wrote in her log that the alignment had felt like a pause in the sky, a moment when the universe let us breathe with it. Others described similar sensations, a quiet internal shift, a renewed sense of wonder, a softened boundary between knowledge and humility. Students working night shifts found themselves asking broader questions about how science handles the unknown. Many noted that the absence of definitive answers was strangely freeing. Instead of closure, they found themselves drawn into deeper thought. The objects had become teachers of patience, showing that not all mysteries exist to be solved quickly. Some are meant to be companions along the long road of inquiry. As winter approached in parts of the world, observatories adjusted their schedules to compensate for longer nights. The objects grew fainter each day, eventually requiring longer exposures and more careful calibration. Their dwindling visibility introduced a sense of farewell. People spoke about them the way one speaks about distant ships still visible, still moving, but moving toward a horizon where vision fades. Fading did not diminish their influence. It enhanced it, reminding observers that fleeting encounters can shape entire seasons of thought. Even the public, once captivated by the dramatic possibilities of the alignment, now viewed the objects with quieter appreciation. News headlines became softer discussions, more philosophical. People wondered aloud what else drifted through the galaxy unseen, what countless mysteries moved in silence beyond the reach of our instruments. The cosmos had become a little larger in the collective imagination, not because answers were given, but because questions had deepened. In scientific circles, some began preparing preliminary papers summarizing observations to date. These reports were careful, no sensational claims, no exaggerated interpretations. Instead, they focused on what was measurable, stable Komae, without tails, unusual thermal behavior, consistent trajectory data, slight spectral anomalies, and the improbability of two such objects arriving so close together in time. The tone of these papers read almost like a form of cosmic journaling, precise but infused with quiet awe. Others speculated about the long-term implications. Could these objects offer insight into interstellar formation processes? Could their dust envelopes hint at conditions beyond the heliosphere? Could their resistance to solar disruption point toward new categories of celestial bodies? The questions multiplied not in urgency, but in gentle curiosity. Discovery had not ended, it had simply changed shape. As the objects continued drifting outward, telescopes began handing off their monitoring duties to more specialized instruments. Solar radiation weakened Komae, thinned, and soon only faint points remained, light carried across millions of miles, diminishing yet persistent. Observers adjusted to this gradual withdrawal with surprising peace. The universe often takes its mysteries with it as it moves. That is part of its rhythm. And so, as another night fell, astronomers stepped outside their domes and breathed the cold air, grateful for what had been witnessed. Nothing spectacular had happened, nothing shocking, but something gentle had unfolded, something that reminded humanity that meaning does not require drama, and that understanding sometimes begins with quiet observation. It's all right to not understand. The sky held its patient darkness, and the two objects now drifting toward the vastness beyond Mars continued their slow departure, leaving behind not answers, but a deeper sense of listening. The universe remains vast, unhurried, and full of questions that unfold only when we learn to move at its pace. As the objects drifted farther from the inner solar system, their faintness became a new kind of teacher. Observatories that once captured crisp details now strained to collect even the most delicate photons. Exposure times lengthened, noise increased, and each data point carried a softness that matched the distant glow of the objects themselves. Researchers felt their presence slipping into the quiet edges of detectability like lanterns, receding into fog still visible but no longer distinct. Yet fading did not mean disappearing. Even at these distances, their behavior continued to offer subtle insights. Analysts reviewing long-span trajectory logs noticed the remarkable consistency of both bodies' motion, as though they had settled into the precise curves defined at the moment of discovery. Natural objects often drift slightly when they pass beyond regions of stronger solar influence, but these two did not drift. They continued steady and unwavering, as if memory guided them more than physics. The thermal data showed similar restraint. As the sunlight weakened, their temperatures declined, but once again the decline unfolded with unusual steadiness. Most bodies cool in uneven patches as internal materials release stored energy at different rates. Yet the profiles recorded here flowed like gentle slopes, smooth and even. Somewhere beyond our reach, something ancient still moves, and perhaps these temperature curves carried some trace of that long motion. Attention turned next to the Komae, now reduced to faint halos detectable only through sensitive filtering techniques. Their persistence at such distances puzzled experts. Typically, Komae vanish quickly once solar heat diminishes, but these stayed thin as whispers drifting around the nuclei with reluctant grace. Some proposed that the Komae might be composed of materials that sublimate at extremely low temperatures. Others suggested a buffering effect, perhaps internal reservoirs of gas. releasing slowly under pressure differences too subtle to measure directly. The dust envelopes continued to defy expectations. Grain measurements still indicated remarkable uniformity and orderliness that resisted typical explanations involving fragmentation or collisional history. The particles drifted outward, but not chaotically. They dispersed in gradients that mapped cleanly onto the object's paths as if following choreography rather than collision dynamics. When compiled into large data sets, the dust patterns resembled filaments that shifted smoothly with each passing week. Meanwhile, theorists continued exploring deeper implications. If these objects represented a new class of interstellar bodies, what might that reveal about distant regions of the galaxy? Perhaps there were places where dust formed differently, where thermal processes shaped matter more gently, or where collisions were fewer and less violent. The idea that these bodies carried the signature of faraway environments felt poetic, like stones worn smooth by waters no human would ever see. Other researchers considered alternative explanations grounded in known physics but arranged in unfamiliar combinations. Could the objects be remnants of ancient slow-moving interstellar clouds? Could they have formed near dying stars where radiation fields shape matter in delicate ways? Each idea carried merit, but none captured all the observations. Even the best models left small mismatches, a curve, too smooth a tail, too absent a coma, too persistent. This uncertainty, though, fostered a kind of intellectual peace. The alignment had reminded scientists that not every anomaly demands resolution. Some mysteries serve instead to widen the doorway of inquiry. These two objects had already done that, prompting collaboration across nations, disciplines, and generations. Their quiet defiance of expectation had become a shared experience, transforming science into something more reflective than competitive. Communities of amateur astronomers continued tracking the objects with the devotion of those who know they are witnessing a fleeting chapter of cosmic history. Using long exposures and careful stacking, they captured the faint glimmers that professionals no longer had time to monitor nightly. Their images, soft and grainy, carried a beauty that transcended precision. Many described a sense of companionship in following the objects, 2 points of light drifting beyond the reach of ordinary sight. As the objects approached the outer regions of the heliosphere, speculation turned toward their eventual departure. When would they cross the threshold where solar influence yields fully to interstellar space? The boundary is not a line, but a gradient, a region where the solar wind slows, mingles with cosmic particles, and gradually loses its hold. Some researchers felt moved by the symbolism, the objects leaving the warmth of our star, returning to the deeper sea from which they came. Meanwhile, students and younger researchers continued analysing the data archives, hoping to find small patterns overlooked in the rush of earlier months. Some discovered minor correlations, tiny shifts in coma density linked to solar flux changes, slight variations in dust spread corresponding to orbital angle. None provided breakthroughs, but each brought a sense of quiet satisfaction. Even the faintest insight felt meaningful when the subject was so gentle in its defiance. In time, discussions drifted beyond the science entirely. People spoke about how the objects had reshaped their relationship with the sky. Some said they felt more connected to the vastness above them. Others said they felt smaller, but not diminished, more aware of their place in a cosmos that rarely rushes to meet human timelines. Many described a renewed appreciation for nights spent in patient observation, the kind that asks nothing but presence. The broader public carried its own version of this sentiment. For months, these anomalies had inhabited news cycles, conversations, and quiet moments of wonder. Even after the alignment passed without spectacle, the fascination lingered not in fear, but in the gentle recognition that the universe is full of things moving slowly in the dark, indifferent yet beautiful. It's all right to not understand. And so the objects continued fading, but never fully lost to memory. Their presence lived on in datasets, in journal articles, and whispered reflections across observatories. They had come from the deep beyond, passed through the warmth of our star's influence, aligned briefly with our world, and then continued outward without haste. No message, no revelation, only motion quiet and steady, reminding humanity how vast the universe is and how softly it speaks. As the objects drifted deeper into the outer solar system, the nature of the research surrounding them began to shift. Observatories still track their motion, but the intensity of daily monitoring softened into a quieter, steadier rhythm. The sense of urgency that once hovered around them dissolved, replaced by something more reflective. Scientists no longer searched for dramatic changes. They sought understanding in subtler forms in the slow evolution of faint signatures carried across vast distances. The object's brightness continued to fade, yet the fading remained oddly consistent. Comets typically lose luminosity in uneven bursts as volatile pockets empty or surface features crumble. Here the decline resembled the dimming of an ember, predictable, gradual, almost graceful. Analysts noted that the curves of brightness resembled long, gentle arcs rather than jagged steps. Even in departure, the objects maintained their quiet harmony. Slowly, a narrative emerged among researchers, the idea that these bodies were not anomalies because they defied known physics, but because they obeyed patterns humans had not yet learned to recognize. Their steadiness, their calm thermal behavior, their cohesive dust envelopes, they hinted at processes shaped over unimaginable timescales. To understand them might require shifting perspectives, not equations. The universe often teaches in this way, nudging humanity toward humility through mysteries too soft to shout. Meanwhile, theorists deepened their exploration of possible origins. Some proposed that these objects could have formed in diffuse molecular clouds, where material accumulates gently without the violent collisions common in planetary nurseries. Others considered whether they might have been shaped by the gravitational tides of passing stars gradually sculpted into symmetrical bodies. None of these ideas fully explained the comae, the thermal profiles, or the absence of tails, but they added texture to the growing understanding that these objects belonged to a realm of cosmic history rarely accessible to direct observation. Radio astronomers continued refining their analyses of the faint ripples detected weeks earlier. Most dismissed them as artifacts, but a few noted that the timing of the fluctuations aligned weakly, not conclusively but curiously with the objects' positions. The idea was not that they emitted anything significant, but that their presence may have subtly interacted with the ambient fields of the heliosphere. If true, this would not imply intention-only uniqueness. Somewhere beyond our reach, something ancient still moves and leaves faint impressions in the space it passes through. As attention turned outward, some researchers examined how the solar wind behaved around the objects. Models suggested that as the bodies travelled into regions where the solar wind thinned, their comae should disperse quickly. But the comae persisted, faint yet coherent, drifting with them, like veils carried through a soft breeze. This persistence hinted that the gases and dust were bound by something more stable than typical sublimation mechanics. Perhaps the particles had been shaped long before entering our system, their cohesion a memory of older environments. A quieter line of inquiry emerged as well, one focused not on the objects themselves, but on the collective human response to them. For months, researchers had watched, measured, debated, wondered. And now that the mysteries were fading into distance, many felt a sense of gentle emptiness, like finishing a book that had changed them without offering resolution. The objects had become intellectual companions, steady presences on nighttime monitors, reminders of how vast the unknown truly is. Some wrote that these encounters had widened their sense of scientific purpose. Others said they felt more aware of the fragility of understanding. Few noted how the objects had softened the culture of competition within astronomy, how they had encouraged collaboration, curiosity, and patience. It's all right to not understand. The objects seemed to embody that lesson, drifting onward in peaceful refusal to be decoded quickly. Public fascination evolved similarly. Early excitement had centered on speculation what might happen, what revelations might unfold. But over time, a quieter appreciation took root. People began expressing awe not at imagined danger or spectacle, but at the simple reality that two interstellar travellers had passed so near visible to human eyes for a fleeting season. Their presence became a meditation on the vastness of existence, on the gentle resilience of objects shaped beyond the reach of our star. As the objects neared the threshold where solar influence begins to wane, the heliosphere itself became part of the study. The region ahead of them, the boundary where solar winds slow and interstellar particles dominate, offered an opportunity. How the objects behaved in this transition could provide insight into the structure of the heliosphere, one of the least understood environments in our cosmic neighbourhood. Even as they faded, they continued to give. With patience, researchers watched as the Comey thinned further. The dust halos lost density, becoming almost imperceptible, except under extremely long exposures. Their trajectories remained quiet lines etched across the celestial sphere, each point of light a reminder of how little force was needed to travel enormous distances. They drifted not with power, but with endurance. And in the wake of this slow departure, a shared sentiment took hold. The significance of these objects did not lie in dramatic change or revelation. Their meaning was woven into the space they opened within human attention, a space for contemplation, humility, and curiosity. They had invited humanity to slow down, to listen more closely to the sky, to notice the small gestures of the universe that often go unseen. Now, as the last detailed measurements were gathered, the objects moved steadily toward the boundary where their signals would grow too faint to interpret. Yet their influence lingered not as data alone, but as a quiet shift in perspective. They had passed through the solar system without disruption, without message, without spectacle, yet they had transformed the way people looked upward. And so the sky grew calm again, carrying with it the soft echo of months spent in collective wonder. The objects continued onward into the deep dark beyond, steady in their silence, leaving behind a reminder that the universe reveals itself not through certainty, but through the endless invitation to keep watching. As the objects approached the heliopause, a new chapter of their journey began, one that no longer belonged fully to human observation. The outermost edge of the solar wind formed a boundary not sharply defined, but gradually woven a region where particles slowed, pressure shifted, and the influence of the sun softened into the broader breadth of the galaxy. To follow the objects into this region required instruments of exquisite sensitivity and a willingness to accept the growing presence of uncertainty. Observations from deep space arrays detected a faint change in the behavior of the surrounding medium. Charged particles near the objects drifted with slightly altered patterns, though the changes were subtle enough to border on noise. Still, the anomalies persisted just long enough to inspire speculation. Perhaps the objects were interacting with the heliospheric boundary in ways that natural bodies occasionally do. Or perhaps their internal structures, whatever they were, responded differently to this transition. Silence is the universe thinking, and here the silence was textured. The Comey, once faint clouds surrounding each nucleus, grew increasingly thin. At times they shimmered in long exposure images like breath in cold air, visible only when the conditions were right, only when the observer knew where to look. Eventually those signatures too began to dissipate. The bodies settled into a quieter phase, shedding less material, revealing less of their nature. It was as though they were preparing for the long darkness ahead, conserving themselves for the interstellar distances that awaited them. Thermal readings became difficult to interpret. The objects cooled in ways that no longer matched familiar curves. Too distant for clear modelling, their temperatures dropped into ranges where many materials behave unpredictably. Still, what data remained showed that the smoothness of earlier thermal profiles persisted even now. No abrupt cooling, no sharp transitions, only the same slow glide into deeper cold. Human instruments strained to follow them, gathering what little could still be seen. The scientific community gradually recognized that the era of close study was ending. Telescopes operating at the limits of their capability could still track the objects as points of light, but finer measurements became increasingly difficult. The Comey faded entirely. Dust signatures dissolved into background static. The last spectral lines blurred into noise indistinguishable from the sea of faint sources beyond. It was not loss only distance, the natural consequence of two travellers returning to realms where light becomes a whisper. Yet the departure sparked new discussions, not about what the objects were, but about what they had offered humanity during their brief passage. Researchers spoke of how the anomalies had inspired collaboration across political and cultural boundaries. Specialists from different fields, spectroscopy, thermodynamics, orbital mechanics, found themselves united in pursuit of quiet understanding. For months the world had looked upward with shared curiosity rather than fear. Some scientists reflected on how the objects challenged their assumptions in gentle but persistent ways. The absence of tails, the uniformity of dust, the serene trajectory curves each contradicted expectations, at just the right strength to provoke curiosity without demanding alarm. Many wondered if the objects represented examples of interstellar diversity humanity had simply never seen before. Others entertained the possibility that nature still possessed methods of shaping matter that Earth's sciences had yet to imagine. A new generation of students found their paths shaped by the mysteries. They entered astronomy not through the promise of dramatic discoveries, but through the quiet wonder of observing something that refused to be neatly categorized. Some wrote that the experience taught them the value of patient watching. Others said it revealed how scientific humility can coexist with bold curiosity. All agreed that the objects had left a lasting impression, even as they slipped beyond the reach of precise instruments. As weeks turned into months, the objects drifted farther still. Their apparent magnitudes climbed, their motion slowed into the gentle arc of receding perspective. Amateur astronomers with long exposures could sometimes catch a glimpse, a faint point against the velvet of deep sky, but even these sightings became rare. Eventually, only specialized observatories continued the watch, marking the progress of the objects as they neared the region where solar particles and interstellar winds blended into a single, gentle turmoil. Within this transitional zone, the objects behaved much as they always had, with quiet resilience. Their trajectories showed no wobble, no unexpected acceleration or deceleration. They seemed to adjust naturally to the changing environment, gliding with the same steady composure they had displayed since first detection. This steadiness, once a source of confusion, now felt almost comforting. Motion without haste, change without disruption. The final high-resolution observations were collected in early spring. Teams reviewed them, slowly savouring the details, knowing they would be the last images sharp enough to reveal anything beyond a point of light. The objects appeared small, distant and serene. Their coma were gone, but their presence lingered in the data, a faint reminder of the months when they had brushed the edge of human attention. As the data tapered, a quiet emotion settled across the scientific world. It wasn't sadness exactly, but something adjacent, a gentle recognition that an era had ended. The cosmos does not hold still for human curiosity. It offers glimpses, encounters, passages. These objects had passed through the solar system in silence, leaving behind not answers, but a shift in perspective. And though they receded now into the long dark between stars, the echoes of their presence remained. In the way researchers approached new anomalies with more patience, in the collaborative spirit that had taken root during their study, in the sense of wonder that flickered in those who'd watched night after night, waiting for subtle changes that often never came. It's all right to not understand. The objects moved on, slipping gradually into regions where solar light could no longer define them, but they carried with them the imprint of their brief passage through human thought, a passage measured not in revelations but in quiet transformation. As the two objects drifted beyond the last clean edge of our observational reach, their signatures thinned into a faint shimmer, barely distinguishable from the quiet glow of the galactic background. Astronomers watched the final detections with a kind of reverent stillness, aware that these were the last measurable breaths of a story that had reshaped months of inquiry. What followed the disappearance was not disappointment, but a deep contemplative calm. The sky had spoken in a softer language, and its silence felt intentional, like a closing gesture offered without urgency. The fading brought clarity, not closure. In the weeks that followed, the scientific community shifted from hypothesis to reflection. Rather than chase definitive explanations, researchers wrote about the humility these events had summoned. Papers examined not only orbital anomalies or spectral irregularities, but the boundaries of human perception and expectation. There was consensus that the anomalies had expanded the emotional dimension of scientific work, reminding observers that uncertainty is not an obstacle, but a landscape of its own. The debate over natural or artificial origins softened into a shared acceptance that the cosmos often reveals itself through partial truths. Answers seemed less necessary than the awareness that we had witnessed something rare. Meanwhile, public attention matured into a quieter kind of wonder. Without dramatic revelations, many found themselves drawn instead to the stillness that followed. The alignment, once a source of collective tension, evolved into a subtle cultural moment, a reminder of how fragile and curious our species remains beneath the vast canopy of stars, conversations centered less on fear and more on perspective. Listener. There was a gentle beauty in how people allowed the unknown to simply exist, no longer demanding interpretation. The quiet that followed the event became a form of teaching. In lecture halls, the story took on new meaning. Professors described the alignment not as a missed answer, but as an example of cosmic patience. Students learned how observation is shaped as much by inner stillness as by instruments. They heard how for a brief moment humanity looked up together and remembered that questions can be as transformative as discoveries. The objects became metaphors in discussions about scientific humility, philosophical curiosity and emotional resilience. What mattered most was not what the objects were, but how their passage altered the lens through which we observed ourselves. Months passed, and the objects slipped into archival memory numbers stored in databases, spectral lines preserved in digital catalogues. Yet their imprint persisted far more deeply than their physical traces. Many who had followed their journey described a quiet shift inside themselves, as though the encounter had reset something subtle in the mind's horizon. It was not awe mixed with fear, but awe softened into acceptance. The cosmos had offered a reminder that not every mystery demands pursuit. Some simply invite presence. In time, the narrative surrounding the objects lost its urgency and took on a gentler cadence. They were no longer anomalies to decode, but companions whose brief crossing through our awareness left behind a stillness that continued to unfold. The universe, vast and unhurried, had allowed us to witness something without promising explanation. And in that offering, many found a place to rest. The mystery remained open, and that openness became its meaning a reminder that it's all right to not understand. Traveller, as the night settles around us, the questions we've carried together soften into something quieter, something easier to hold. The new object between 3i Atlas and Earth drifts on untouched by our certainty, unmoved by our fears, continuing its silent path through the dark. Whatever these visitors are natural wanderers or instruments of intention, their presence has already changed us. Not through revelation, but through reflection. Tonight the universe whispers again, reminding us that observation is its own kind of message. Our steps, our choices, our cooperation or division, all of it becomes part of what we send back into the vastness. And the vastness listens in ways we may never fully understand. Perhaps that is the quiet truth beneath this mystery, that we learn who we are by watching what we notice, by how we respond to the unknown, by the humility we bring to the cosmic threshold. We are small, yes, but not unseen. We are fragile, yes, but still capable of wonder. So let your breath slow. Let the sky widen above you. Whatever waits in the distances beyond sight will unfold in its own time, with or without our readiness. For now, it's enough to rest in the knowing that the mystery continues and that you are here to witness a small part of it. Rest well, traveller. Stay curious. The universe will keep watch.